Yes, sir. Yeah. Roughly. I mean, it's a matter of probability. You've got more people interacting with cows. So. From an odds perspective, there's not much difference. What do you got? 7 billion people on the planet at the moment. So. Shark cow. Probably half of those are rodeo. Get underneath a bull and get a hoof to the chest. It's not a good outcome. Okay, so the bells are ringing. Seneca appears to be on fire. So we will move forward. I don't know how true that is, but it's very smoky out there on the quad. So lecture 10, this will be the last lecture that appears on our exam 2 weeks from today. So we have a lab tomorrow. We're asking you to bring some clothes that you don't care too much about. Things are going to get pretty smelly. I'll show you how best I know how to clean up all that stuff to try to get the smell off. We will wear gloves in an effort to minimize all that potential problem, but it's going to stick with you. At least you're going to smell it in your nose for a couple days. So we got a lab makeup today at 5 o'clock up at the dairy. So we got 1, 2, 3, and then we still got to schedule another makeup for lab 4. Maybe we'll do that at the makeup this evening. Review sessions next 2 Mondays. Our exam on the 5th. Any questions about any of that? Okay, let's see what we got here. So you two ready for any questions? I'll be putting out the buckets this afternoon, so they should be filled by like 7 o'clock tomorrow morning. So anytime you want to take care of that. So we're going to continue to define our cows here. More or less, we're talking about dry matter intake. Last time we talked about how dry matter intake can influence how much milk is produced. There's a direct correlation between the milk that is produced and what she ate. You can pretty much guess on a herd basis how much they ate 3 days ago, which is why when the heat comes, the heat first affects dry matter intake, and then 3 days later, milk drops, or 2 days later, milk drops. So you have those issues. So if we can get 45 pounds in, we discussed last time, we get 75 pounds of milk, assuming protein is the most limiting. If we can get 55 there, we can get 95. So that 10 pounds difference is going to equal to about 20 pounds of milk, more or less. What happens if we restrict or we have problems with intake? Cow needs 8.2 pounds to produce a certain amount of milk. What does that do to the concentrations? We said nutrient intake, which is the column over here on the left, is a function of dry matter intake times the concentration or percentage. So looking at that, if we take the dry matter intakes we had in the previous example, how does that affect? We do our math, figuring that out. How does that influence our percentages? So we have at 45 pounds in dry matter intake, we need 18.2% crude protein to get her the pounds of crude protein she needs. If I can get up to 55, I'm down to 15%. It's a whole lot cheaper, probably about $1 a cow, to do the bottom diet than it is to do that top diet. There's a lot more grain associated with that 18% than there is with that 15%. So if I can get more intake, encourage more intake, a lot of good things happen for that cow. So this is the plot. I think this is this past August. We do our dry matter intakes on a daily basis. So we're looking at our high group, pen 2. Up top here, going across, we're usually in the mid-60s for them. So because we have that intake for those animals, we have the opportunity to lower the costs of the rations, to have a little less nutrient density, feed a little bit more forage, a little less grain. Pens 4, our fresh group, and that's the red line. And then our first calf heifers, our smaller animals on the other side, they eat about the same. We're looking usually at the mid-50s, lower 50s as a dry matter intake. Then we have a couple other groups there, the springy heifers, the dry cows. They're going to be about half of what the lactating cows eat. So that graph there, we update those once a week. They're posted outside the records office there if you want to keep track of how we're doing. We had a discussion here where we're getting our dry cows. That's the pen 16 here. We're down in the 20 range. Something wasn't right. And it turns out we weren't writing the proper amount of feed that was fed down correctly. Because if they were actually eating only 20 pounds on an average basis, there would have been a lot of fresh cow problems, and there wasn't. So I said it has to be a math problem. And it turns out we weren't accounting for everything the way we should have. So factors affecting dry matter intake. If I can get 1 more pound of dry matter intake, I have the opportunity to be more profitable. Or at least that's the hope. So there are a lot of factors that influence dry matter intake. If I can increase dry matter intake, usually to the better, but there are things that are going to work against that increase. So we have a list right here. And we'll discuss as we go through how to be with each of these factors increase or decrease dry matter intake. So as you can see there, we've got a lot of things affecting that. So let's work our way through. Let's start with body size. The bigger the animal is, the more she can eat. So if we want to increase dry matter intake, we have larger animals. If we want to reduce dry matter intake, we have smaller animals. You can see that in the comparison of that graph. Pen 1 up there, first calf heifers are smaller than our mature animals. They're eating 55 versus 62. So definitely eating less. So as they get bigger, they have the opportunity. You also saw in that graph what production does. The cow seems to produce, and that drives her hunger, her desire to eat, and dry matter intake follows. So the more production we have, the greater the dry matter intake. As we go down in production, we lower the need. her appetite reduces, she's sated more often, she's going to eat less. So body size, production are probably the two main factors that we use to predict dry matter intake. And we can get pretty close on a group level if we are diligent about recording our body size and diligent about doing our production. Water availability. How much water do I have? How good is it? The more water I have, the more she will consume. So if I can increase water availability, water intake, she's going to consume more. And that goes back to that rumen being a very wet environment. I need a certain amount of water in there to process that feed. If I don't get that water in there, I have to have less feed to process. So reduce water availability. I'm going to decrease intake, increase water availability. I'm going to increase. The ration will influence how much she consumes. If I have a balanced ration where everything is roughly right, generally she will consume more. If I have an unbalanced ration where something is way out of whack, they tend to back off. If this ration is not healthy, or what you're asking her to eat is not healthy, she will back off on her intake. So we try for a balanced ration. Everything's working the way it should. That balances the rumen. That gives her what she needs to produce. That's going to drive the whole system and increase or encourage intake. Forage quality. If it tastes better, they generally eat more. So if it's more sugary, if it's fresher, if it tastes good, she's going to eat more. If I got rot mixed in there, if I got old stemmy straw, old worn out, I'm going to have less intake. If I've got something fresh, soft, all the high quality factors associated with our hay judging, we're going to have higher intake. So when we're looking at forage quality, we're going to mention that word or phrase in different contexts. One, it was sort of like our judging the hay. How good is the quality there? We do a more analytical approach. What's the digestibility of that forage? So people use forage quality to describe the digestibility. If we increase the digestibility of that forage, specifically the NDF, we are going to increase intake. That digestibility, we talk about BMR corn silage, more digestible forage, we have more consumption. That animal will produce more. As the forage quality goes down, it becomes more stems, no leaves. We have higher NDF, higher ADF, higher lignin contents. That's going to reduce the digestibility and therefore the intake. So if you want an animal to be kind of stuffed, get her some straw and hopefully she'll eat it. You might have to put some molasses on it or something like that. Feed access or availability. Does that animal have access to feed? Is that feed within reach? One of the concerns that we run into on farms is if we feed in the morning, as the day goes on, cows tend to push that feed out of reach. There may still be feed in the bunk, but if they can't reach it, that bunk is empty. So that's why we need to push up multiple times a day, especially if we have some sort of flat area, as opposed to, everybody know what a J bunk is? So J bunk, in theory, a cow sticks her head through, the concrete is shaped in such a way that the feed will always slide down toward her. The problem with those is cleaning those out, and that's not fun. So it's a whole lot easier if we have a flat surface, push it up. as the day wears on, as we get closer and closer to the next feeding time, if we're doing every day, that feed gets out of reach a whole lot faster. When I used to work up at Minor Institute, the night milker would try to push up feed in the middle. They're supposed to push up feed before and after each milking. He goes, I need to push it up more often during that last milking before feeding because they're just pushing the feed out of the way. There isn't as much, it's lighter. You got slick tile, it's just moving out of the way. And these cows are looking for feed after they come back from milking, so sometimes I have to be a little bit more aggressive. So do they have access? Do they have feed in reach? How many days is that bunk? How many hours a day is that bunk empty? So if there's feed within reach, we increase intake. If there's no feed there, cows are looking around. It's kind of like that empty free refrigerator syndrome, right? Go and look in your refrigerator, nothing there. Go around, sit around, go back. Hopefully something's materialized, still nothing there. You're wasting time where she could have been have eaten and fallen asleep. Feeding management. So how do we put together a ration? How do we make sure that things are delivered properly? So providing a good mix on a ration, that what comes out of the mixer is the same at the beginning and end. If we start to separate stuff, where we got more fiber on this end of the bunk and more grain down here, you're going to upset the rumens. You're going to lower intake. So good feed management is going to increase intake. Poor feed management, such as not mixing correctly, delivering the feed improperly, maybe taking too long to get there, maybe not mixing things up as good as we should. One of the concerns right now is we don't have the knives aren't sharp in our mixers, so we can't put hay in there and have that hay reduced. So the cows are going to sort against the rest of the diet and favor that hay. Feeding frequency and feeding times can influence intake. Does anybody know from other classes, when does a cow like to eat? Naturally, if they're out on pasture, when are they going to usually eat? Assuming they're not milking ridiculous amounts of feed, which means they're going to eat all the time. How many deer hunters I have in here? When do you go out after the deer?
Or dawn or so before sunrise.
So either end of the day is when deer tend to want to eat. It's the same with cows. They have a natural tendency at sunrise and sunset to eat. So we'd like to foster that by making sure feed is available at those times. So that's called corpuscular. Either end of the day, that dusky area where light is starting to fall, they tend to come out and eat. Feeding frequency. If I bring feed, fresh feed multiple times a day, I tend to, within limits, increase feeding or feeding by the cow. If fresh feed shows up, especially in the Southwest, that feed shows up multiple times a day. When that gets there, the cows tend to go right to the feed line and eat. So it's usually a law of diminishing returns. Mixing feed 4 times a day, delivering it 4 times a day is not a good return on our investment, but sometimes 2 is, especially in the summer if things are heating up. We might get a benefit there by mixing things not quite as much, letting them eat it down, and then bringing in a fresh feed if we're doing a fresh defacing with each feeding. So increased feeding frequency, letting a cow eat when she wants will increase intake. In our management systems, another thing to consider is the time as they come back from milking. We want feed available. So that's tie stall, free stall. We want feed there so they can eat. So desire to eat is after milking and at either end of the day. Feeding sequence. So if I'm feeding things separately, I'm doing hay here, I'm doing grain here. As a general rule, and there's a lot of controversy on this, if I feed forage before grain, I balance the rumen out a little bit more. As I keep that rumen balanced, I should get more intake. If I feed energy before protein, I should balance the rumen a whole lot better. One of the things I did when I came home from school is we started, instead of feeding high moisture corn twice a day, dovetailed with protein twice a day, we went to 3 times a day and split the carb. So you go down one aisle feeding the energy, come back feeding the protein. So you're effectively feeding that at the same time. Butterfat went up 6 points. So balancing the rumen out, you're going to have more intake. So feeding sequence, forage before grain, energy before protein seems to work, but there is certainly enough research out there that says that doesn't make a difference. But it's usually a context issue depending on the cows. Ration changes. Cows like the same thing every day. If we can be consistent at the same ration every day, we are going to promote intake. If we keep jumping around, if we can't get our mix right every day, especially this past week with all the rain coming in, trying to get the forages right has been a challenge. John's been working extra hard. It's like, what should we do for dry matter today? What does that represent? Well, the face got soaked. You got that puddle of water down there. What's the dry matter? If we don't get that dry matter right, we have a different ration every day. The cows get upset stomachs. They tend to back off from eating. So if we can minimize ration changes, keep things the same every day, make slow changes, we're going to promote intake. Abrupt changes, like if we don't adjust to the water that fell Monday, the rain that came down on Monday, if we don't adjust to that, we're going to underfeed forage. We're going to hit that rumen. There's going to be acidosis. The cows are going to get upset stomachs. They're going to back off on intake. So consistency helps promote intake. Inconsistency and changes decrease intake. Feed bunk management. Are we keeping that bunk clean? Are we cleaning it on a regular basis? Are we pushing out the orts or at least pushing them down to the end? Do we have a nice clean surface that doesn't smell like last week's feet? We can keep that bunk clean. We can encourage intake as we build up the rot, as there's stuff in there. You stick your nose in there and you don't want to smell that, you're not going to eat. We could also say feed bunk management if we're managing our faces on our silo, so we don't include rot. A little bit of rot in the mix will drop intake dramatically. So when I was coming up through about your age, I say, well, it's only a couple inches on the top. We don't have to fork that off. It'll mix in. They won't even notice. That little bit on a 10-foot face backs off intake 10%. If your intake is 55, you drop to 45, you lost 10 pounds of milk per cow. So taking the time to get that rot off the top is well worth it. So we don't want to mix that in. We don't want to do that. Moisture content. The general consensus among nutritionists is if I get things too wet, I'm going to back off intake. They seem to like that 40 to 60% dry matter or moisture range for feeding diets. That middle area seems to get the highest intake. The question I have is like, okay, pasture is only 10% dry matter, 90% water. Why don't they seem to have problems with that? Of course, you can't eat pasture just because of the mechanics of it all, but green chop, they could probably eat as much. So, but that middle range seems to optimize intake. As we get too wet, we run into trouble. And I think that's more not a function of the water itself, but what happens to the silage if it's too wet. So it has a funky fermentation, and we'll hopefully get examples of that as we move forward in lab. So the environment will influence. If you've got a good environment, you're going to increase intake. If you've got a bad environment, too hot, not well ventilated, not comfortable, you're going to reduce intake. So we need a well ventilated barn. We like a lot of cow comfort, what they lay on, what they're doing with. Comfortable cows eat more. Uncomfortable cows, bad environment leads to reduced intake. Social interactions can influence intake. If you have one super dominant cow, they can spend all their time denying other cows resources. I'm going to stand here and I'm not going to let anybody near the bunk. So that reduces her intake, and that reduces every other cow's intake. If you have a cow like that, you probably should get rid of it. But the social interactions, the dominant cows, the subordinate cows, increase stocking density, where you have more fights over limited resources, will reduce intake. So you want to have a cow that's comfortable, knows her place in the hierarchy, and can find a time where she can get to that feed. So you need to allow each cow to be a cow. So if we limit the social interactions, control them, keep them at a reasonable level, we should increase intake. As we increase where things get hostile, there's a lot of pushing and shoving, we're generally going to decrease intake on the entire group. Health. This one's pretty straightforward. You don't feel good, you're going to not eat anymore. Healthy animals eat more. So if their health is good, they get through the calving transition without any problems, they're going to eat and be producing milk very well in a short period of time. If they don't feel so good, they're just not going to eat. So bad health, reduced intake. So down the side, we've got are these animal factors, the right side, feed factors, or human factors, management. So body size, that's an animal issue. Production, that's an animal issue. Water availability, ration, forage quality. Well, I guess water availability is a human issue. I guess it would be best to say that ration, forage quality, and its two things there are feed issues. Feed access availability, feed management, feed frequency, feed sequence, ration changes, bunk management, those are all under human control. Our ability to do what needs to be done will influence how well we do that. Ration moisture content's a feed issue. Environment, we're going to blame that on the humans. If you're confining that animal, not letting her get away, the environment is your responsibility. Social interactions would be animal, and so would health. Any questions on those? So a lot of things are going to affect dry matter intake. So if we can find out the dry matter intake, we can have a fairly good idea of how well the nutrition program is going. To me, it's one of the top 10 things I want to know when I go onto a farm, so I get a feel for where they are. Because there's so many things have to come together to get dry matter intake proper. So a whole lot of things affect dry matter intake. So it's a good measure of a program. So if you're looking at this list, so it should be your top 2 slides there. Maybe, yeah, you've got a slide farther down that's the same. What do you think has the most influence? Take a look at that for yourself, and you're going to share that answer in a minute. But what do you think is going to have the biggest effect on dry matter intake? So you've got a list. Compare your answers with your neighbor or group, however you want to do it. Put those influence or what you think the top 3 influences are on a piece of paper, and this will be a team quiz. So if you want to work together, you can work up to 4 people in a group. If you want to work together, come up with your top 3.
Yeah, okay. Oh, that's great. Yeah, great.
So everybody got a top 3 or need a couple more minutes? How should I interpret the silence? Still working?
Yeah.
Okay, you're still working, okay. Just needed to know. So top 3 for your group. Make sure you put your names on here. Looks like everybody's got something. So how many people had body size on their list? One person from the group, raise your hand. Production. Water availability. Fashion. Forage quality. Forage quality again. Digestibility. Feed access availability. Feed management. Feeding frequency and times. Feeding sequence. Ration changes. Bulk management. Feed bump management. Moisture content. Environment. Social interactions. Health. So you could probably argue that any of these could go and be in the top 5 depending on the circumstances. I'm probably going to go with body size, production, and today I'll be throwing my third one in there as environment. So, but you could easily argue those, so everybody gets 100 on the quiz, but I want you to think about that. So pass that quiz in. So how do we maximize dry matter intake? Everybody got their names on? How do we maximize dry matter intake on a farm? What are some good practices that we'll put together? So always having fresh feed in front of the cows and have it within reach. So in a tie stall, that means you're pushing up feed, sweeping feed multiple times a day. You're running through with some sort of push-up machine or a robot in our free stalls. Anytime a cow goes to look for feed, there's something there. The refrigerator is never empty. So we're looking at an average dairy cow does 10 meals a day. So having feed there when they're looking for it is important, and having it within reach. High quality and a lot of quantity of water. We don't want to limit water intake at all if we can avoid it. We want to balance our rations. We want to mix things up if we can and deliver our rations properly. We want to give the nutrients to that cow that they want. So we want to have a high quality, highly digestible or fermentable ration. We want that cow to want to eat that feed, tastes good, smells good, and when she consumes it, she will be able to extract as much nutrition from it as she can. We want to change slowly. So right now we're looking at, okay, we're going to try to get a fourth cutting. Given our bunk situation, fourth cutting's got to go in front of first. We need to probably open our second cutting bunk probably here this week. So we can start doing 50-50 mixes for a week or so before we'd have to shut down that other bunk. So gradual changes, looking at the dry matters and what we enter in the TMR tracker program up there. I don't like to move more than 2 steps at a time, 2 percentage points. If you look at the haylage up there, it's all over the place. Last Thursday, you guys got 32. Friday and Saturday, I got 41 and 42. We got another 40-ish on Monday, but we're bouncing all over the place, and I think it's a question of the sample. There are some spots on the face that are really wet and other spots that are not, depending on how well the sample that goes into the bucket represents what's there. We're mixing, we're rolling, we're quartering, so we should have a representative sample of what's in the bucket, but the question is, are we sampling correctly into the bucket? So I don't want to jump anywhere. You guys did that sample. I think we brought it down. I didn't jump down to 32 in the program. I brought it down to 38. We were at 40. Let's do 2 steps at a time, and then I'll check it again. So we're holding at 38 at the moment. We're probably going to need to work our way back up. So we continue to get those dry samples. We'll see what Thursday gives us moving forward. So healthy cows in a good environment. Our healthy cows are going to eat more. If they've got a good environment, they're comfortable, they're going to eat a whole lot more. We want to keep our cows chewing and ruminating. That's going to help process the feed in the rumen. That's going to help buffer the feed in the rumen. Two things that are going to promote that fermentation, and we're going to extract as much as we can out of that feed. So how do we monitor dry matter intake? I said it's a very important thing to do. What do we do to do that? The first thing you have to have is scales. We have to have some indication of what feed is going in there. For those of you in 200, we'll spend a week on just this part. Been on farms, it's like, well, we don't have a battery, so we don't know what we're putting in the mixer anymore. Boss won't pay for a new battery for the mixer wagon. Just put in what you think there. You're going to have variability on a daily basis. You don't know what's going in those mixers. You don't know how much of each ingredient. There was another farm we went on, and I went on it and jumped on the mixer wagon. I was 130 pounds. I haven't been 130 pounds since wrestling season in high school. So the question is, what's the problem? There's lots of things you can figure out. For a while, we were having trouble with our mixer wagon that the load cell was labeled wrong by the factory, said install this way when it should have been this way. So we could never get a consistent weight. It's like, this is not right, you know. So having scales and making sure they work, you have to know the amount of feed that's offered to a group of cattle or an individual cow, if that's the way you're doing it, and then what is refused. How much disappears? We assume the difference between fed and refused, we call that feed disappearance. It went somewhere. We assume it goes into the cow. But some of our cows like to throw feed all over the place, so it may not end there, but we assume that's negligible. We need to use our moisture tests. We need to know the moisture content of the feeds that we're working with to figure out dry matter intake. And we need to know how many animals are in the group. How many animals are there? And sometimes that's easy. And sometimes we've got animals like a fresh pen going in and out all the time. How many animals are there in a given day? And then once we collect all that information, we calculate dry matter intake, figure out the numbers. And then if we're really going to communicate it to everybody, graphing it makes the most sense. Looking at a column of numbers, it's hard for me to get a feel for it, but like if I graph it, I can say, okay, we're up, we're down. It shows that the human mind responds to the pictures better. So how do we calculate dry matter intake? What do we need to know? There are 5 things we need to know to calculate dry matter intake. We've alluded to them all already. I need to know the weight of the feed that was fed. How much was put in front of those animals? I need to know the dry matter percentage of that feed. So I'm putting an as fed weight in front of those animals. I have to know how much dry matter is there. Dry matter intake. So how much water is there? How much dry matter is there? I need to know the weight of the refused and the dry matter percentage of that refused. Now, depending on the farm, that dry matter percentage might be a whole lot different than what was put in front of that cow. And then I need a number of cows. So if we're looking at dry matter intake, we're trying to do the feed eaten over the number of cows. That's our ultimate thing there. That's why we need the number of cows. Like if I don't have that information, you have a 0 on the bottom. What happens when we divide by 0?
Get 0.
No, you can't do it. It's an explosion. It's bad. So if you have a 0 on the top, you have 0, but you can't divide by 0. You need a special Mylar suit for that. So if we're looking at what the cow eats, we're making the assumption that the difference between what I put in front of that cow and what she refused is what the cow consumed. So we need to break that all down onto a dry matter basis. So this will be a lab in probably 2 weeks. If I multiply the amount of fed by the dry matter percentage, I get the pounds of dry matter fed. If I take the refused, multiply it by the dry matter percentage of the refused, I get the dry matter refused. So dry matter fed minus the dry matter refused gives us the dry matter consumed. We divide that by the number of cows. We should have the dry matter intake per cow per day. That is our standard expression of that. The question becomes, which of these are easy to get and which of these are hard to get? So you have a slide there if you want to color code it. Easy is in green. The hard is in tan. If we have a good mixing system and a scale that works on our thing there, if we're keeping track of our dry matters, the fed side of the equation should be easy to get. If we're not doing that, there's no point in doing dry matter intake. If you don't know what you're feeding on a day-to-day basis, there's no point in discussing dry matter intake. So if you've got a good feeding system, that fed information, those two numbers there, should be part of your system. The challenge is the refused pounds and the refused dry matter. So refused pounds, what do I have to do to get refused pounds? So you have to weigh it. What does that usually involve? Skid steer, pushing stuff around. You're going to need something solid to push against to get that feed into the skid steer bucket. And we don't want to use the front of the partition there because you'll blow it out over time. So we usually need some sort of block down at the end that we can run against, pick it up. So, and then you got to have a system that you have, when you're picking up with a skid loader, you have to be able to get it back into the weigh wagon or the feed wagon to get it measured. Now at Minor Institute, the skid loader that cleaned up the feed bunks was not tall enough to get into the mixer. So doing weigh back every morning, which was necessary for the research, involved two people. One with a small skid steer, the other was a large front end loader. So the skid steer would push it into the front loader would go out and dump it in the wagon. That's where they get their numbers from. So this is not easy to do. Number of cows, it depends on your system. The amount of animals going in and out of a group, if you've got daily changes, that becomes tough. Milking in a group, that should be pretty straightforward. There are lots of places where the number of animals that went through from a group should be recorded. How many animals were milked for that pen? How many animals are in that pen? That should be a little bit easier. So the number of cows can be difficult, or number of animals can be difficult and also easy. With dry matter intake, what do we absolutely need to get the job done? We definitely need the amount fed. We definitely need amount fed accurately. We need the amount of dry matter fed accurately. And we need to know the number of cows. Without those three, those dry matter intake numbers are meaningless. We can fudge or guess with the refused. The pounds of refusal, the dry matter of the refusal, and it's not going to make a huge difference because it's such a small part of mathematically of the equation. There are the challenges therein. But we need those other three numbers or there's no point in doing it. So I have a quiz for you as you work your way out the door. As soon as you're done, you can be on your way. Everybody ready? Quiz question jar is up front. Any questions while I'm passing these out? When you're done, drop them off in the front. You're free to go.